Hi everyone. In this video, we'll be working on a SQL case study. This case study is part of 8-week SQL challenge. If you go to this website, 8weeksqlchallenge.com, there are 8 case studies in total from case study 1 to till case study 8. We'll be working on all the case studies. In this video, we'll be working on case study 1, which is Danny's Diner. If I open this, if you click on this, read more. The problem statement is Danny has a restaurant, which is a Japanese restaurant, and in this restaurant he sells 3 items: sushi, curry and ramen. See, Danny is smart, so he collected some information about his operations. He also has a customer loyalty program where there are exclusive offers for the loyal customers, and Danny knows that using data I can make smart decisions and make his business more thriving and more profitable, but he doesn't know how to do that, how to take those insights from the data. So this is where you and me comes. Simply, Danny wants us to help him by taking this data and answering some questions he has so that he can make better decisions and run the business. Now he provided us 3 tables. See, sales, menu and members. He has 3 customers: customer A, customer B and customer C. And from that, as we said, there's a loyalty program. Only customer A and customer B are part of this loyalty program. Customer C is not part of the loyalty program. Now he gave us the sample data and he has few questions and he wants us to solve these questions and give him insights so that he can run the business better. Now if we take a closer look at the tables, we have sales, we have menu and members. Sales and menu are joined on product ID. See, product ID is a common column, and also sales and menu are joined on customer ID. We have customer ID here and the customer ID in this. So sales is a fact table, menu and members are the dimension tables. Also, all these icons are taken from flaticon.com. So this is where I took all these images from, all these icons from. Again, they should get the credit. So now let me show you how I approach this case study. There are 2 steps in this approach. One, the visual explanation of the query, then writing the query from scratch in an SQL editor. So let me show you the second step first. So if you see, so this is what we do generally. We load the data in an SQL editor and write the code step by step. Finally, we get some output. But I do it differently. So what do I do? First of all, before writing the code, we solve the same question visually first, step by step manner. So what do I mean by that? For example, if you take this data, we have a table called diner data. This is the output. This is the table information. Now the relevant code to get this information is simply select star from diner data. Generally, we write the code and then we get the output, but I flip the process. First of all, we see the output and then we write the code. The idea is to visualize the output we want and then write the code in SQL to get that output. So let me show you one more step. If you see here, what we want to do, we want to exclude data where order date is greater than or equal to join date. We have order date column, also join date column. If you see this row, January 7th equal to January 7th. Again, we want to exclude it. Order date is equal to or greater than join date. We want to exclude this information. And also January 10th is greater than January 7th. Again, so all these 4 rows will be excluded. Even here in customer B, we exclude these 3 rows because January 9th is the join date. So how do you see it visually? You can simply color code it. So these rows satisfies this condition, but these rows does not satisfy the condition. So now how do you write this in SQL? Simply, to do this, we can simply write a where condition, right? So once you know which rows does satisfy this condition and which rows does not satisfy this condition, when you write the query and get an output, you know whether the output you got is actually what you want. And also, even if you see, a lot more is going on in the code. At first, we see it in pink color. If you see, always the new lines of code will always be in pink color and also in different font. The old lines of code will be in black color and handwritten font. See, at first this is the code, that's why it's in pink color. This is a new code, and then we are writing the where condition. We already written this code, we already seen this code, that's why it's in black color. The new lines of code always in the pink color. Again, why only black and pink? If you see the case study, the branding colors are black and pink. That's why I used the same colors to indicate the differences. Again, the old lines of code are in different font, not only the color but also the font. Also new lines of code also in the different font. as I mentioned here previously. Again, this design consistency is followed throughout the case study. So for every query, we see two things. One, SQL transformation visually at every step. Two, corresponding SQL code following a design consistency, just like this. Now, if you see here, we have few more transformations that are going to happen. This is the final output, and also this is the final query. And then finally, after seeing the code visually, step by step, we go to SQL editor and write the code. Again, we write the query line by line. So this process of seeing the code visually and then writing the code step by step is followed throughout the case study for every question. So let me show you once. So there are 12 questions in this case study. For all the questions, so if you see, so this is question number 1. For all the questions, we follow the same process. So if you see here, we have question number 10, and then 2 more bonus questions, question number 11, and also question number 12. We follow the same process of seeing step by step, and then finally writing this code in the SQL editor. Now the question is, why go through all of this? Why not just write the code directly? So again, I have 2 reasons for it. So let me show you. Let me go back. Yeah. So the reason number 1 is visual learning. We learn best visually, again also step by step manner. Once we know at every step what's going on, it's easy to grasp those concepts. And also the reason number 2 is multi-concept queries. Again, in my experience, I've seen that most people have difficulty when they encounter multi-concept queries. For example, most people can write the query if it has one concept. Suppose if the query needs joins, they can do it. If the query needs window function, they can do it. Be it dense rank, rank or row number, lag, lead, anything. But when you give a query where we need all these concepts, where you need to perform a window function, and then you also need a join, you also need a CTE. This is where most people falter and how everything is interacting with each other. So even in this case, this visual step-by-step learning helps you a lot. Again, so to give an example for multi-concept queries, let's go for question number 5. Again, I'm not going to teach the question now itself. I'm just showing the reason for this type of teaching. So if you see, in this query, we started select star from sales details, simple select statement. And if you see the final query, this is the final query. Here, multiple things are going on. We have group by, and there are 2 columns for group by. Also, we have not one CTE, we have 2 CTEs. Again, we have a dense rank, which is a window function. And finally, we are performing a where condition. See, we have multiple concepts going on this query. So if I directly write the code, most people may not understand what's going on. But if you see visually, we started here, and then again we have group by, and at every step we add only one idea at a time. Slowly we build the code along with these visuals. Again, even if you see in window function, we write the whole code, but at first we will only focus on partition by. What happens at partition by level, and also what happens at order by. After partition we have order by. What happens at this level, we have partition by, we have order by. And also what happens when you write a dense rank, you get a new column once you write a dense rank function. So at every step we see one idea at a time, and slowly we build on everything. Again, even here we follow a pattern. Always the visuals are at the left side and the code is at the right side. Let's show you. All the visuals are at the left side and then code is at the right side. There is a proper design consistency and a proper visual pattern that's followed throughout the course for every question. Visuals are at the left and also code is at the right side. Same for every question. Again, in this case study, we have 12 questions. In all the 8 case studies combined, we have 150 questions. Again, 150 questions in total. Again, we will follow the same visual pattern, the same design consistency for all the case studies. I want to make you one promise that I won't be abandoning this challenge no matter what. As we know, there are 8 case studies. We are done with case study 1. Okay, remaining 7 case studies we will be completing. There are in total 150 questions in this challenge. Within this case study, we have 12 questions, which means we have 138 questions more to complete. I promise you, we will be completing them. I promise you, we will be completing them. The reason I already completed writing the code for all these 150 questions. The code is done. It's completed. Now I am working on the visuals. I also completed 90% of the visuals for next case study. I am working on remaining case studies too. These visuals are taking more time than I anticipated. And also I'm just one man army. So give me some time. Please be patient. I will be completing them. The hope is to complete it by end of this year. Again by end of 2025. I want to complete it as fast as possible. I just that don't want to compromise quality over speed. I know hope is not a strategy, but let's hope. Fingers crossed. So now let's focus on setup. And this is the GitHub link. I will provide the GitHub link in the description. So go to this link. Control C. Yeah, go to this link. And if you go here, this is the folder we are going to download. Simply click on code. Click on this. Click on download zip. And this will be downloaded. Please store it somewhere in your local folder. Save it. If you go, I saved it on desktop. Again, a zip file is downloaded. Click on it, right click and extract all. Click on extract all. Again, please untick this. Don't tick this. Untick this and extract. See, a new folder is extracted. And click on this. Click on this again. And here we have case study 1. Again, similarly, you will have all other case studies too. There is a case study per folder. For every folder, there is a separate case study. So for right now, we are working on case study 1. Go to case study 1. We have 5 folders. The same pattern, same format in every case study. So ignore these two. I literally mentioned ignore this folder. Ignore it. In this 4, let me show you what are the contents in each folder. If you go to visuals, you have one Excalibur file, which is exactly the same file. If you see the same file where all the visuals are there, this exact file is in this folder. Now go to data. The data files related to each case study will be in the data folder. You can file all the files here. And then if you go to solution script, again, this is my script. If you want to run my code, you can upload this in Databricks. I'll show you how to do it. And practice scripts, this is where we are going to write our code. So please try to upload this and work on this. Don't create a new notebook because I already provided you the questions in this folder so that you don't have to copy from the case study itself. That's it. The same pattern will be for every case study. Visuals, data, solution script, and the practice script. Also, I took the screenshot for every step and pasted here. So if you have any difficulty following me, you can actually go to these screenshots and do it on your own. So every step is mentioned in detail. Now let's go to Databricks and create an account. Go to databricks.com. See databricks.com. Click on login. If you login, you will get a sign up option. If you already have an account, click on login. And if you don't have an account, click on sign up. And it's again simple Google sign up. Go to Google and please provide your Gmail account. I already have an account, so let me show you process. Again, sign up as a new user if you don't have an account. You will get a 6-digit code to your email. Please verify your account in Databricks with that 6-digit code. If you don't see your code in the inbox, please check the spam folder because when I signed up, the 6-digit code email was in a spam folder for me. So try to check that, and also then sign up for personal account. It will give you two options, work account and personal account. Please sign up for personal account. That's enough for us. So once you log in, this is how the interface will look like. And we'll be focusing on this left panel. In that, again, for us, the only thing that is important to us is workspace and catalog. If you see, workspace and catalog. In workspace, this is where we store all the scripts, SQL scripts we write. So in workspace, we'll be storing all the scripts, either solution script or practice script we'll be storing in the workspace. And we'll be storing the CSV files. These data files we'll be storing in catalog. So again, we'll go step by step with that. So let's first of all store data. Okay, before that, let me show you the Databricks hierarchy. That's very important. So if you see in Databricks, we have at the top layer, we have a catalog, and within catalog, we can store multiple schemas. Again, you call it schema or database, it's one and same. And then within database, we can store multiple tables. So we are going to organize all our 8 weeks SQL case studies in this format. Let me show you. First of all, we are going to create a catalog which is called SQL challenge. And then we are going to create 8 schemas, one for each case study. Case study 1 as diner, case study 2 is pizza run, and final case study will be fresh segments. And within case study 1, we have 3 tables, sales, menu, and members. We are going to create these 3 tables within this diner schema. And this is how we are going to organize all our case studies. So now let's go to Databricks. Let me go to my account. Click on catalog. We are going to create a new catalog called SQL challenge. Again, if you have any issue following me, you can please go to the screenshots. I took all the screenshots and clearly mentioned every step. But I also show you here. But if you have any issue following me, you can look into this. You look into the screenshots step by step. So let's go to catalog and click on this plus button. Create a catalog. Click on this. Create a catalog. And let's give a catalog name SQL underscore challenge. Click on create. And close this. If you click on this, we see we have a new catalog called SQL challenge. So now we create a catalog. Let's create a schema. If you see, this is done. SQL challenge catalog is created for us. Now let's go to diner schema. Again, click on this catalog and click on this create schema. Again, please try to go to SQL challenge catalog and click on this schema here on the top right. Create schema. Schema name is again for case study 1 it's diner. Give everything as same. Click on create. So this is created. Again now and if you see the same process again. Now SQL challenge and diner is created. Now we need to upload this. Now we have to create these tables and upload those files. If you see again within this SQL challenge, click on this SQL challenge. Click on diner. We have no data now. Again click on create. Click on table. Click on table. Click on browse. See within case study 1. Within case study 1 diner. Click on data and you have 3 files. We will be uploading one at a time. Click on members. Open. A cluster is being started. If you see, we have customer ID A and B and we have joined it. Again, the issue here is that joined it has to be in the date format, but it's in string. Please don't try to change it here because if you change, you will get null value. So keep it as is, keep it as string. We will deal with this issue via SQL code and click on create table. Now if we reload this, see we have previously we have diners, no data. Now we have one table which is members. Similarly, let's go for sales and menu tables. Again, click on diner, create. Again, please try to click on diner and then create and table. Similarly, upload menu table. Again, price as integer. This is product ID as integer and product name as string. So create data. So create table. See the table menu is being created. And then again, if you refresh this, menu table is created. Now finally, let's create the final table. Create table, browse and sales. Again, if you see clearly, it's also mentioned here. Catalog is SQL challenge, schema is diner, and also table name is sales. Again, this sales table name is picked from the file name itself. The file name was different. Again, if you also change here, you can also change here sales. And also, see here we have no issue. Here the order date is picked as the date format itself. But for members table, it picked as string. We will deal within the SQL code. See again, customer ID as string A, B, and C. Also product ID as integer 1, 2, and 3. Now create table. Now we are done with the setup for the data. If we refresh this, we have 3 tables: members, menu, and sales. If you click on diner, if you see details, again suppose again it's not showing here. Suppose if you refresh the page, see 3 tables are created: members, menu, and sales. Now we are done with this. Now the data part is over. Now we need to upload. Again, see all the steps are completed. Now we are going to upload SQL scripts. Please go to workspace and here create a folder. Then click on create a folder. Let's call it again. Let's create a folder for all the case studies. We'll call it 8-week SQL challenge. Create. Within this, we are going to create 8 folders, one for each case study. So again, click on this within SQL challenge. Again, you can also go here. Again, see we have 8-week SQL challenge folder. Click on this. Again, create a folder. We have case study 1. Case study 1 as Danny's Diner. Then click on create. Now let's upload those scripts. Click on these 3 buttons. Click on this import. Again, browse. Again, let's go to within this case study 1. Go to practice scripts. Click on this folder. Click on this file. Open and then import. See, this is what we are going to work on. Okay, if you click on this, see, I already mentioned you everything. You don't have to copy paste all those questions. The questions are also mentioned. That's for this case study. This is the file we are going to use, and in this file we are going to write all the SQL code. Okay, now we are done with the setup. All of this is done. Now let's see how this notebook works. If you don't know, please, it's very simple. There are only few things we need to focus on. Before we start solving the case study, there are few settings we need to make. One, please make sure this is SQL by default. Database supports multiple languages. If you see, set the default language for this notebook. New cells will use the chosen language. So if you make SQL by default, when you click on code, the new cell will be SQL by default. If you make Python by default, see Python by default, everything will be, and if you click on new code, it will be Python. Because they are working on SQL case study, please make sure to click on SQL and make it default. Click on this SQL, that's setting 1. And also, if you want to run a cell, for example, if you see, we have catalog as SQL challenge and schema is diner, right? Let's load these tables. It's very simple. Click on plus button, code, right? Select star from SQL challenge dot diner dot members. Again, we have to mention all of this when you want to load a table. SQL challenge, the catalog, the diner, the schema, and also the members, and the table name, which is members here. Let me zoom in. And if you want to run this, we have to click on this button, run cell. Before that, we want to connect to a cluster. If you see, click on this connect, click on the serverless. It will take few seconds to connect. See, it's connected. And you can, if you want to run a whole notebook, click on run all. If you want to run a particular cell, you can click on this run cell. Again the shortcut is control plus enter, or also shift enter. You can do either control enter or shift enter. If you click on control enter, it will run. It's running now. If you want to interrupt, you can click on this. If you don't want to interrupt, let it run. So if you see, we have customer ID and join date. Again, we'll deal with this string later. And then, okay, you can also load other tables too. SQL, select star from SQL challenge dot diner dot menu dot sales. Let's do this. Again, click on Shift Enter or Control Enter for shortcut to run the cell. See, we have 15 rows. We have three columns: customer ID, order date, and product date. So please make sure to, again, one more setting, one final setting. Go to View, click on Side Panel, or click on Appearance. Please untick this Automatic Assistant Autocomplete. Please untick this. Again, it's by default it's ticked. Please untick this. Yeah, that's it. That's the only setting. Again, now that we completed the setup, let's solve the case study questions. Let's solve this date format issue. Simply, let me do this. Click on new line, click on new cell, select star from the SQL challenge dot diner dot members. We see what we can do is simply customer ID, and then okay, let me use the join date. We can do simply to date format, to date, join date, and also let's provide the format we have. We have month, we have date, month, and year, right? So DD, capital M, capital M is month, small m is minutes in date formats. So capital M and then small y 4 times because we have 4 digits for year. If you run this, see, if you see here, initially it was join date was ABC, which is string, and if you see here, date, it's a date format now. So simply rename it as join date again. See, again, it's in a date format now. Now let's remove this, and also we have to override this table, right? If you run this again, so this is what we want. This is the table we want. Initially it was this in string. It's now in date format. Now this is the table we want. Now if you see, the issue is we are displaying the output, but we are not storing it. What does it mean is, if you again run SQL challenge, okay, let me take this SQL challenge dot diner dot members. If you run this, see, it will be still string. So we have to override this with this new information. So for that, what we can do is to create or replace a new table. Replace this old table with new table. So for that, the syntax is create or replace SQL challenge. Again, we are storing in the same location. So the same catalog, SQL challenge, again, create or replace table SQL challenge dot diner dot members as this code. Again, that's it. So if you run this, see again, so it's not done. So if you rerun this, see, now we have proper format. Now it's a date format. So now that the setup is completed, let's focus on solving the case study questions. So if you look at the tables, I have 3 tables: sales, menu, and members. Now if you see the questions, we have 10 questions in total, along with 2 extra bonus questions. So in totality, we have 12 questions to solve. I already mentioned for every question which table you need to solve these questions. Except for question number 2, all the remaining 11 questions, either we need sales and menu table or sales, menu, and members table. So which means for every question we need to perform joins. Either you join sales and menu for few questions, and also join sales, menu, and members for few other questions to get the query. Which means you are performing joins repeatedly, which I want to avoid. So what I did was, so I created 2 more new tables for these join tables. So what I mean, so what I did was I created a new table called sales details, which contains inner join on sales and menu. So from now on, when I'm solving a question which needs both sales and menu table, I can instead use sales details table rather than sales and menu separately. So we can avoid performing joins every time. Also, I created another table called diner data, which contains a resultant output of all the three tables. So first I performed join on sales and menu. I performed an inner join. We got a sales details, again similar to the first one. And then on this output, I joined a members table and also performed an inner join. We got the diner data. Instead of using these three tables, sales, menu, and members, we can use sales details and diner data when we are solving the case study questions. So now let's see in detail how these sales details and diner data tables are created. So if I show you, so if you see, so sales and menu, inner join, sales details, again simple. Okay, now let's see it in detail. So we have sales table, we have menu table. Okay, the column, the common key that's joining sales and menu is product ID. We have product ID, product ID. You see, product ID column and the product ID column. So if you see the relevant code, select star from, we can't just provide the table name. We need to provide the whole hierarchy, the catalog, the schema, and the table name. So SQL challenge, we already created this catalog, we already created the schema, we already created the table. See, SQL challenge dot diner data dot sales. Again, we are joining it on SQL challenge dot diner dot menu. Again, on which column we are joining it? What is the join condition? Sales dot product ID equal to menu dot product ID. If you see, once you run this code, so once you run this code, this is the output you get. We have two product ID columns here, one from each table. This is from sales table and this is from menu table, because both of them are giving the same information for us. So having two columns which gives the same result becomes redundant for us. We don't want to store it. So we are only getting the one column. So how do you do that? See the code. So we are selecting everything from sales table. So basically we are taking the product ID column from the sales table. And then we're only taking the relevant columns from the menu table, menu.product name and menu.price. So this is the output we get once you run this code. And then finally we are creating a table out of it. Why? Because so once you run a SQL code, the output is displayed. The displayed output is not stored. So we have to create a table to store it. So to store this output as a new table, we're going to write the syntax. You see, create or replace table. Again, we need to provide a particular location and a proper table name. SQL challenge dot diner dot sales details. This is the new table name we are providing. As again, we are writing all this code. If you run this query, this new table is created. So now if you write the code, select star from SQL challenge dot diner dot sales details, because now we created this table, you will get this output. From now on, you can use this table to solve the subsequent case study questions. So this is the final output, and this is a whole query, final query. Now let's go to Databricks and write this query and create this table. If you in Databricks, select. So please try to connect this. Don't forget to connect this. Select star from SQL challenge dot diner dot its sales. At first you have sales, and then you are joining it with SQL challenge dot diner dot menu. If you run this code, again, what is the join condition? On sales dot product ID equal to menu dot product ID. If you don't provide this condition, we will be performing a cross join. Again, now we have two product IDs, one from each table. Again, so we are selecting sales dot star. So everything from sales, customer ID, order date, and the product ID. And then from menu table, menu dot product name, and also menu dot price. So if you run this, so now we go to the table. Again, we have to store this table because it's only displayed, it's not stored. So for that, simple syntax is create or replace table. Again, we have to provide the location, SQL challenge dot diner dot, again, new name. Previously we did members, right? Because you are overwriting it. Now we are not overwriting anything. We are creating a new table. So provide a new table name. So sales details as, run this. See, a new table is created. If you run this, click on code, select star from SQL challenge dot diner dot sales details. See, new table is, you can see the new table, sales details. Okay, now let's create the diner data table. The first part is same as sales details. Joining sales and menu table, perform inner join, sales table, menu. Also, we are getting this output again, same as sales details output. The code is same, so there is no change. Sales and menu again joining on the product ID column. Now here on this output, on this intermediate output, we are performing a new join, which is members table. So if you see, members table has a customer ID column, and also this output has a customer ID column. We are performing these two tables on the customer ID column. So if you see, join, so this for this old query, join SQL challenge.diner.members on customer ID, sales.customer ID equal to members.customer ID. So this is the, once you run this query, to show you, once you run this query, this is the output you get. And if you see, we have redundant columns here again. We have two customer IDs and also two product IDs. We only want one customer ID and one product ID. We are selecting the necessary columns. How do you do that? Again, sales.star. Again, same from menu, we are only taking product name and price. From members, we are taking only the join date because customer ID is already taken from the sales table. So once you run that code, we get this output. Also, we are creating a new table out of it. So how do you do that? Simple. Create or replace table, SQL challenge.diner data. So please don't forget to provide the catalog, the schema, and the table name. If you forget it, it will be directly stored in the default. Either default catalog, which is not what we want. That's why we are specifically providing the catalog name and the schema name and the table name here. And then run this code. A new table is created, which is diner data. So this is the final output. This is a table we are creating. And this is the query we run to create this table. Now let's go to Databricks and create this table. Okay, now let's create this diner data using all these three tables. So simply select star from SQL challenge dot diner dot sales. Again, we are joining it with SQL challenge dot diner dot menu. So if you run this again, don't forget to provide a join condition and keep on forgetting it. So sales dot product ID equal to menu dot product ID. So if you run this, so that's join one. So one more join, we are joining it one more table, SQL challenge dot diner dot its members. Now we are joining with members. Again, if you provide, again by default it's inner join. I forgot to mention this. By default it's inner join. If you want to provide, if you want to do left join or anything, suppose if you want to do a left join, provide this inner. If you provide either inner, or if you don't, if you just provide nothing, it's still inner join. Again, hoping you're providing a join condition. Otherwise, it would be a cross join on sales dot customer ID equal to members dot customer ID. Yeah. If you run this, we got this. Again, we only want few columns. Sales dot everything, comma menu dot product name and menu dot price and members dot what is it? Join date. Yeah. And if you see, it's in the date format. So if you run this, see again we got the output. Again, we are not displaying the output, we have to store it. We have to store this information for further use. So simply click on this. So create or replace table SQL challenge dot diner dot new table name diner data as, and run again. See again new table is created. If you run here, select star from SQL challenge dot diner data. See, we can see the output, customer ID, order date, and all the remaining details. Again, here we only have customer A and customer B because customer C was not a member. Now, isn't this annoying to do every time to write the catalog name, the schema name, and also the table name every time we use it? The better way to do is use this catalog and schema as defaults. When you make them defaults, then you can directly refer to this table name. Now, how to do that? Use this code, use catalog SQL challenge, and use database diner. Using this code, we are making SQL challenge as a default catalog and diner as default schema. Again, schema or database both are same. Then we can write select star from diner data. What we can do is, to make our life easy, we can write use catalog SQL challenge, use schema diner. So if you run this, and please make sure to have this semicolon, otherwise you will get an error. See this, it will consider error. So have a semicolon here, or you can write this in a new line. You can remove this, you can remove this, run this, and run this. Yeah, any way you want. Again, this will be default till you have this cluster on. Once you stop this cluster, and again if you restart it, this will not be default anymore. Suppose if you see, let me show you this. Now if I show you, select star from diner data. So if you run this, now we get the output. See, we don't have, because we made SQL challenge and the diner as default. Now suppose if I stop this cluster, so click on this connected, again click on terminate. Okay, don't show again, terminate. So now again it's terminated. Now let's restart it again. Click on serverless. See, it's connected again now. Okay, now run this again. See, now we get an issue because SQL challenge is not a default catalog. So that's why every time you stop this cluster, if you made this catalog default, you have to run them again. So every time you restart the cluster, please make sure to run this code. So semicolon and this semicolon. Yeah. So let me remove this. So run this and run this code. Now it works. So please don't forget to run these defaults when the cluster is terminated. Let's go for question number 1. What is the total amount each customer spent at the restaurant? So basically we have 3 customers, right? Customer A, customer B, and customer C. How much each customer spent in totality? So if you look at the table, we have sales details. Select star from sales details. There's the output. Now, because we want to know for per customer level, you can simply perform a group by on customer ID. See, simple group by on customer ID. Now we can visually group the whole data into 3 segments based on the customer ID. So this is for customer ID A, which is in the orange color, and for customer B, it's in yellow color, and customer C, it's in blue color. You can visually see how data is divided into 3 segments based on the customer ID. How group by works? Group by simply works on the split, apply, and combine method. So if you see how the split happens, so if you take this whole data, this will be split by the customer ID. So if you see customer A, customer B, and customer C, it's split into different segments. That's how split is happening. And then here we are taking the relevant columns for the next step. So if you see, we want price and we want the customer ID. So when we perform summation on the price column, we get the total amount spent. So that's why we want two columns, customer ID and price. Okay, same for every segment. Now then the apply function comes. So if you see here split, and now we are performing the apply. In the apply step, we are performing the aggregation. If you look at customer A, if you see, we're taking customer ID A. So if you add up this price, it comes to 76, and we are renaming it as a total amount spent. Same for customer B and same for customer C. We performed split, we applied the aggregation, and now we are combining the data again finally. All the split data will be again combined, and then we can see the output. This is the output. So if you see the code, at first we write the group by customer ID, and then if you see, we are taking the relevant columns, customer ID, and then we are performing summation on price, sum of price as total amount spent. And finally, once you run this code, we get this output directly. We get customer ID, customer A spent $76, customer C spent $36, and customer B spent $74. Now we are performing a order by total amount spent in descending order. Now if you see, the customer who spent most amount of money will be at the top and the least will be at the bottom. Customer A who spent $76, which is the highest, is the top, and customer C who spent only $36 is the bottom. And this is the code for the order by total amount spent in the descending order. Again, this is very important, descending, because we are putting the customer who spent more amount at the top, right? That's why descending is important. And then finally, if you see, this is the final query and this is the final output. Okay, now let's write the code for question number 1. So let me write this: select star from sales details. If you run this, again we got the output. If you run this again, group by customer ID, also customer ID, and then summation on price column as total amount spent. So if you run this, again finally let's also perform a order by clause, total amount spent in the descending order. Again we got the output. So we can see customer A spent the highest amount, which is $76. Now let's go to question number 2. How many days has each customer visited the restaurant? See, if you particularly see in the question, it says days rather than visits. For example, I went to the restaurant morning, afternoon, evening. It will be, the number of visits will be 3, but number of days will be 1, because within 1 day I went to restaurant 3 times. So the distinction between number of days and number of visits is very important. Here we're looking for the days rather than visits. So now let's see the solution. See, the table we need is sales. So I already mentioned you, this is the only question where we need sales table. For remaining all other tables, we either need sales details or diner data. If you see sales, select start from sales, this is the output. We have customer ID, order date, and product ID. Here, order date is the most important column for us. If you see, again, we want per customer, right? It says how many days has each customer. Again, we are looking for the each customer per customer level. And so we can simply perform group by on customer ID. The whole data is segmented into 3 parts: customer A, B, and C. See, again, because we have 3 customers, the data is segmented into 3 parts. If you have 1000 customers, the data would have been segmented into 1000 parts. Now let's see how group by works. Simply the split, apply, and combine methodology. So the data is first of all split based on the customer ID. Again, because we are performing group by on the customer ID based on customer ID, and then we take the relevant columns. We want customer ID because we want that output in the customer level. Also, we want the order date because it shows how many days the customer visited. So the relevant columns are customer ID and the order date. So we are taking those columns. And then if you see, as I mentioned, we are looking for the days, right? Not visits. So if you see, let's focus on one customer, customer A. Customer A went to the restaurant 6 times. 1, 2, 3, 4, 5, 6, 6 times. But how many days? On January 1st, 2021, customer A visited the restaurant 2 times, but it's only one day. And also on January 11th, went to the restaurant 2 times. Basically, this is one day, 7th is one day, 10th is one day, and the 11th is one day. Because 4 days, in total 4 days. But we have 6 rows. So we should find a way to only calculate it once. Same for customer B and same for customer C. So for that, you can simply perform distinct on order date. Once you perform distinct, you only get the unique values. So if you see, once you perform distinct, this is the output. January 1st and January 11th are only considered once rather than twice each. Same for again customer B. There are no duplicate values in the order date for customer B. And customer C, we have again January 1st, customer C went to the restaurant twice. So it's only selected once. So if you see the code, so we already seen select star from sales group by customer ID. Again, here we are selecting the relevant columns, customer ID and the order date. So we are discarding basically the product ID column. And then if you see, we are performing distinct, right? Distinct order date. So we are picking the unique order dates per customer. Now finally, we are performing count on this distinct order date. So customer A went to the restaurant 4 days and customer B went to the restaurant 6 days. If you see, the number of visited days is 4 and here 6. And finally for customer C, it's 2. So the code will be count on this distinct order date. We are renaming it as visited days. See that this is the output 4, 6 and 2. So we are combining all the data. Once you run this code, we get this output. And finally, we are performing order by on the visited days. So the customer who came to the restaurant, the more number of days will be at the top and the least will be at the bottom. So customer B came to the restaurant 6 days. Customer A came to the restaurant 4 days and for C it's 2 days. So this is the final output and the query. Once you run this query, you will get this output. Now let's go to Databricks and write the code. Select star from again sales details. Again, you can also use sales because both of them contains the same sales information. So for consistency, I'm keeping the sales details itself. Control enter. Now again, group by customer ID. Again, because we're looking at the customer level, customer ID. Again, we want distinct order ID. Distinct order date. Again, we want count rate. We combine this, put in a bracket, count of distinct order date, which gives the visited days. We run this. Again, here also you can perform a order by to sort the output. Visited days in the descending order. We run this. We can see customer B who visited the restaurant 6 times is the maximum. Okay, now let's focus on question number 3. What was the first item from the menu purchased by each customer? Again, even in this question, we need sales details. Again, just like previous 2 questions, here also we need information at customer level, which means we need to perform group by. But here the twist, we don't want the aggregated result because that's what group by gives us, aggregated results. Here we want first item, which means we want product name information. What was the first product for each customer? So we cannot aggregate product name. Now what we want in the result, customer and the product name, that is the first product name they purchased, which we cannot aggregate. So what we can do is we go for a row level information. So previously, if you see for question number 1, let me zoom out. Yeah, if you see question number 1, previously if you see here the result is at customer level, but the information is aggregated information. But same for question number 2. Here also we have information at customer level, but the information was aggregated information. But in question number 3, we don't want that. if you go back to question number 3, we want information at product level. Again, product name we cannot aggregate. We cannot perform summation of sushi, curry, and ramen. We cannot do that. So we can only take information at row level. So for that, we cannot use group by. So the other option we have is window functions. So we are taking partition by customer ID. Again, similar to group by. Information is divided into segments based on the customer ID. So we are performing partition by customer ID. We have 3 customers. So 3 segments or 3 partitions. We have 3 partitions A, B, and C. And the question says we want first item in customer level. So let's focus on customer A because the same logic will be applied for remaining partitions. So within this, we want the first item. So how do you get the first item? We can perform order by on the order date. The first order purchased by the customer in this restaurant. So customer A purchased the first order on January 1st. So customer A purchased 2 items, sushi and curry on the same day. So we can consider both of them as first item because we don't have any timestamp information. We only have the date. So it could be that sushi was purchased in the morning and curry was purchased in the evening, or both of them are purchased at the same time. So we don't have that additional information of timestamp. So that is why we are considering both of them as first product. We can perform order by on the order date in the ascending order because we want the first item. So this is the output we get for this partition for customer A. And then finally we add another column to indicate the numbering, to say this order is the first order, this order was second order. We add a column called purchase order rank. This is the first order, January 1st. Okay, on January 1st, customer A made the first order, so that's why the order rank is 1. On January 7th, the second order was made, that's why the order rank is 2. Now here the order rank is 2, which means that we are using dense rank, not a rank. If you are using a rank, the order rank would be 3 because dense rank does not jump from rank to rank, it goes sequentially. But rank function jumps the ranks. So that's why the order rank is 2 because we are using dense rank. Then on January 10th, the third order was made. That's why here 3. Again, similar to January 1st, on January 11th, 2 orders were made. That's why both of them will get the order rank equal to 4. And the same logic will be applied for remaining partitions. Now let's see the code on how to implement this in SQL. If you go back to the top, so we had partition by here. So if you see the code here, we clearly have partition by customer ID. At first, we are performing a partition to create these 3 partitions, and then we are performing order by on order date in the ascending order to get the first item at the top, and then we are performing dense rank to indicate the numbering for these orders, and we are calling the name purchase order rank 1, 1, and 2. That's why, because we are using dense rank, it's 2. If you are using rank, it would have been 3. Here it would have been 1, 1, and 3. If you are using a row number, which it would have given 1, 2, and 3. Because we are using dense rank here, it says 1, 1, and 2. Now we got the numbering of these orders. Now what we want is only the first item. We don't want all the items. We only want the first item. Further, we need to use this purchase order rank, which is a derived column. Filter the orders where rank equal to 1 to get the first items for every customer. To do that, because we are using a derived column, we need a CTE or a subquery. So again, as I said, my personal preference is CTE because I rank readability more than anything else. That's why I'm using a CTE. We can also get the same output using a subquery. Okay, it's a personal preference. So with CTE as select star from CTE. Now we are able to use the purchase order rank after creating the CTE, where purchase order rank equal to 1. So the order rank equal to 2 does not satisfy the where condition. That's why this row will be discarded. Same for customer A, customer B. All these rows will be discarded where rank is not equal to 1. Same for every partition, we are looking where purchase order rank equal to 1. So finally, these orders satisfy the condition where purchase order rank equal to 1. And from that, we are taking the relevant columns, which is customer ID and the product name, which is the first item from every partition. And we are selecting customer ID and product name. Finally, when you run this code, you get this output. So this is the final output, and this is the final query. So now let's go to Databricks and write the code. Now let's write the code. Select star from sales details. Control enter. Okay, now we got the output. Now as we said, we need customer ID information and the first product name. So for that, we can simply do dense rank over partition by customer ID and order by order date in the ascending order. In the ascending order, by default it's ascending order. It's better to indicate as purchase order rank. Okay, now if you run this, okay, we got the purchase order rank. Now we are using this derived column. So for that we need a CTE select star from CTE. Control enter. Again we got the same output. Now where purchase order rank equal to 1. Now we are going to get first item for every customer. We only want the relevant columns as customer ID and then product name. So if you run this, now we got the output. Customer A information is in 2 rows and also customer C information is in 2 rows. But what if we want in only 1 row, and you can indicate all these products by a comma. We don't want A sushi, customer A sushi and customer A curry. What we want is within 1 row customer A, and then in product name we want sushi comma curry. What if we want all these multiple orders to be indicated by comma separation? So if that was a requirement, so for that what we can do, we can, let me copy this code, and as version 2, this comma separation is our version 2. So here we need to perform a group by, because we want customer information in only 1 row. So for that we perform group by customer ID, and then we do is, what we do is string ag. This is the function to create the comma separation, and then we have comma and space. So if you run this again, this is first items, first ordered items, first ordered items. If you run this, if you now see, we have customer A, sushi and curry are comma separated rather than in 1 row each. Same for customer C. And for customer C, we have ramen comma ramen. Again, it looks like duplicate, but this is to indicate this product was ordered 2 times. Now let's go to question number 4. Now let's go to question number 4. What is the most purchased item on the menu and how many times was it purchased by all customers? So if we see, we have 3 products, sushi, curry and ramen. We want to know which was the most popular item. So which means the popularity comes from quantity, right? How many times each customer bought all these products. The product which was sold the most will be naturally the most popular item among all our customers. So we want to know that which was the popular item among these 3 products. You see, we are taking sales details table, select star from sales details, is the output, and then we are performing based on the product name, because previously we were looking at customer level. Now we want to look at the product level. We want to know the most popular item. So we are performing group by product name. See, all the ramen will be in the red color or orange color, sushi are in the yellow, and the curry is in the blue color. Group by works on split, apply and combine methodology. We are splitting the data in 3 segments because we have 3 products. If we have 4 products, we would have seen 4 segments. We have ramen, we have sushi, and we have finally the curry. And then now we want to know the count. We can simply perform count on this data on number of rows. We are taking product name, and then we are performing the count on everything. Either we can see the count of star, or we can also do count on the particular product column itself. So count on product name will also give the same count. For sushi it's 3 and for curry it's 4. This is the code. We are selecting, again we have group by product name, we are selecting the product name, and also we are performing the count on the product name. Even if you do count of star as product count, you will get the same result, because anyway you are counting the row only once. So that's the output, and then we split the data, we perform the aggregation, and then we are combining the data at the end. We have ramen which was bought 8 times, sushi which was bought 3 times, and finally the curry was 4 times. Now we are ordering the data in the descending order because we only want most popular item, right? We only want one product. We are ordering based on the purchase count itself in the descending order. The most sold item will be at the top. So ramen is at the top. We have sushi at the last because sushi was the least sold item. See, the code will be order by purchase count and descending again. So the popular item will be at the top. And finally, we only want one item. So we can limit the rows to 1. If you see, This is final output. We only want this output. For example, if you're using any other SQL editor like PostgreSQL or SQL Server, you write top one. Rather than limit one, you write the top one at the top. After select, you write top one to get this output. Because I'm using Databricks, and even if you're using MySQL, we have something called limit one here. Once you write limit one, only the first item will be shown. So we can clearly see ramen was the most popular item among all our customers. So this is the final output, and this is the final code. Now let's go to Databricks and write the code. Select star from sales details. Now we want the most purchased item, which is the most popular item. So group by product name. Again, previously we were doing group by and customer ID because we want the output at the customer level. Now we want the product level. So group by product name. So product name, comma, count of everything as product count, product purchased count, purchase count. So if you run this, so you can see ramen is the highest, which is 8 times. So we can do order by product purchase count in the descending order. Now we got ramen at the top. Now we only want most purchased, only one item. So it's limit one. So if you're using SQL Server, you can write top one at this. Suppose if you use SQL Server, you can write top one. So this and we can, because there is no limit one function in the SQL Server. So now let's go to question number 5. Which item was the most popular for each customer? Previously we saw most popular item among all customers. Now we are looking for every customer. Just because an item was popular for among all the customer, it does not mean it's popular for each and every customer. So that's what we are going to find. We want to check whether ramen, which was a popular item, is also popular among every customer, or is it popular just for few customers. Again, the interesting thing in this question is, if we go to the final query, if I show here, every concept we know till now, every concept we learned till now, CTE, group by and window function, all of them are going to be used in this query. We have a group by, one column but two columns, and also we have dense rank, and we have not one CTE but two CTEs, and finally we have a where condition. So now let's solve the question. So if I go back, so again we started here. We want sales details table. Select start from sales details. For each customer, again at customer level, same like question number 3, we want item. Previously we looked at for each customer the first item. Now we are looking at popular item. So for that, let's perform group by first to get the customer at customer level. A, B, and C can be performing into 3 segments. So if you see, we have A, B, and C. Again, now let's also look at only one customer, because the same logic is applied for others too. Here we have information about only customer A. Now we want popular, which means volume. So customer A bought sushi only once, and curry twice, and ramen twice. So it clearly shows ramen is the most popular for customer A. Now how do you do that in SQL? We can again perform a group by on product name to count these products. So if I show you that, so again if you perform a group by within this customer, that's why we perform group by on 2 columns. First in customer level, and then within each customer level we are performing on product level. So we see we have one row to indicate sushi, so only one. For curry it's 2, and for ramen it's 3. Now if we count this, we can clearly see 1, 2, and 3. So if I show the code, here we are performing group by, and then we are performing count on product name. That gives us for customer A, sushi is 1, curry is 2, and ramen is 3. So for sushi, for customer A, for sushi it's 1, it's 2, and for ramen it's 3. Again the same logic is performed for each customer. Now from this we want to indicate that ramen is the top because this has the most purchases by customer A. To indicate, we need a numbering column. Again, to create a numbering column, again we need a window function. Again, finally, this is the output if you run this code. Once you run this code, this is the final output you are going to get. And on this, we are going to add a numbering column to indicate that for customer A, ramen is the most popular. For customer B, it's all of them because customer B bought in equal quantity. Quantity is 2. And for customer C, luckily we only have one product. Customer C brought only 3 products and all of them happen to be ramen. Now let's add this numbering or ranking column. Here we are using this column, product purchase count, to indicate the ranking. Again, this is a derived column. So we need a CTE at first. We write the CTE, and then on this product purchase column, we are performing the dense rank. We are performing the partition by customer ID because for every customer, and then we are ordering it by product purchase count. Again, we are performing the descending order because the most popular item has to be at the top. And then finally, we are performing a dense rank. Then let's go to customer A. And once you perform order by, a ramen will be at the top because the product purchase count is 3 and we are performing product purchase count in the descending order. And finally, we are ranking it as 1, curry as 2 and sushi as 3. For customer B, all of them will be 1 because we have 2 purchases for each product. And for customer C, we only have 1. Again, we should add, again, I think I missed it here, but we will have one more column. It says rank equal to 1. Again, I'm sorry for this mistake. And finally, we combine them and this is the output. Now, if you see for customer C, we have this column. So this is the output. Once you run this code, this is the output you are going to get. Again, we are filtering by, because we only want the popular item for each customer, we are filtering it by purchase and equal to 1. Again, to filter out, we are using this ranking column, which means again this is a derived column from CTE. So we need another CTE to use this column. So for that, we create one more CTE as CTE2. So we write CTE2 select star from CTE2 where product purchase rank equal to 1. So these two records does not satisfy the condition and they are discarded. So this is the final output we have. From this, we only want these 2 columns, customer ID and product name. So that's what we are selecting, customer ID and product name. So this is the output, customer ID, product name. This is the output. So this is the final output and the final query. So we see, so now we know we need 2 CTs. We used group by on 2 columns, a dense rank and also where condition. Again, if you see in this output, customer B has 3 rows. We can indicate them again by comma separation. You can say customer B, curry, comma, sushi, comma, and ramen. Again, further, again, we need a string aggregation, just like we did in question number 3. So we'll do that as version 2. So let's go to Databricks and write the code. Okay, let's write the code. Select star from sales details. Control enter. Again, we got the output. So group by on customer ID and also on the product name because we want the most popular product for each customer. Customer ID and product name. Now we want count of product name as product purchase count. Again, you can use count of star or count of product name. Now let's use this column to create the numbering. It's CTES select star from city. We can also give a bit more meaningful name. Let's say product rank. So we can use product rank. Okay, now we can perform a dense rank over partition by customer ID, sorry, no comma, and order by product purchase count in the descending order because we want the popular one at the top as product purchase rank. So if you run this, yeah, we got for customer A, ramen is at the Again, we are using this to filter out the popular items. So again, we need a CTE popular product as. Again, sorry, one more thing I forgot to say. Only for the first time you use with clause. For remaining cities, no matter how many cities you write 10, 20, 40, 1000, 10,000. We don't use the with clause again. Instead, we use comma separation. We separate one city from the other city using this comma separation. That is something I forgot to tell you. So here we are using comma, and also we are writing a new name without any with clause. So if you write here, select star from popular product. So if I run this, so we have product purchase rank. Again, the same city. Again, now here we are writing where product purchase rank equal to 1. So this is the output we are looking for, and the columns are customer ID and product name as popular product, or most purchased product. So yeah, now let's take this again. Now let's write this in comma separation. So Control A and Control C. Let's do it as version 2. Again, as we know, we need to perform a group by on customer ID. Group by on customer ID. Group by on customer ID. Again, we are performing string aggregation. String aggregation on product name, and we are performing a comma separation. So if you run this, see curry comma sushi comma ramen. Now let's go to question number 6. Which item was purchased first by the customer after they became a member? So from now on, we are seeing membership information. If you look at the original tables, we have total 3 customers, right? A, B, and C. But only A and B are the members. C did not become a member. So if you see, you can clearly take diner data for this. Select star from diner data. We have information about customer A and customer B because they are the members. Now what we want to do is, want to know the first item they purchased after they became a member. On January 1st, customer A bought an item, but on January 2nd, on January 7th, customer A took the membership. Simply this order does not belongs to customer after becoming membership. This item was purchased before they became a member. But if you take this item on January 10th, customer A purchased ramen. This item was purchased after they became a member. So we want to flag this, and we want to fetch only orders that were made after becoming a member, and then we want to fetch the first order. So if you see, the code would be where order date greater than or equal to join date. These two are flagged as not satisfied, and these 4 are flagged as satisfied. Now when we fetch it, when we run this code, so once we run this code, we get this output. And now in this, we want to know for customer A, the first order was curry, and by customer B, the first order was sushi. We want to fetch these items. Now what we can do, we can simply rank the orders for every customer based on the order date and fetch the first order. So if you see, we can simply perform partition by. If you see, for customer ID A, when we perform okay, we have only 2 partitions because we only have 2 customers here. You can see partition by customer ID, and then we are ordering the data based on order date. Again, we want the first item, right? First order that was made after they became a member. You can clearly see this is the first order. So we can order the order dates in the ascending order. So January 7th order will be at the top, and January 11th, which was the latest order, will be at the bottom. Same for customer B. We can order the dates based on the order date in the ascending order. So if you see, order by order date in the ascending order. And finally, we have a new column called order rank. We have a new column order rank. The order that was placed on January 7th is first order. So order rank equal to 1. And on 11th, there are 2 orders. But again, the order rank is 3. Same for customer B. The January 11th was the first order after becoming a member. 11th order was the second order. So order rank is 1. And on 12th, there are 2 orders. But again, the order rank is 3. Same for customer C. The 11th January 11th was the first order after becoming a member. 11th January 11th was the first order after becoming a member. it was order 1. Now we want to only want this order rank equal to 1. So if you see, if we combine the data, and now we want to use this order rank, right? Which means, again, this is a derived column, which means we need a CTE. So if you see, again, which CTE as select star from CTE. Now we can simply write a where condition where order rank equal to 1. If you see, where order rank equal to 1. Now we can see we have only two orders, one order per customer, and these orders are purchased right after they became a member. And again, finally, we are selecting the relevant columns, customer ID and the product name. See, customer ID and product name. So this is the final output for customer A. Curry was the first item after becoming a member, and for customer B, it's sushi. Again, now let's go to Databricks and write the code. Okay, now let's write the code for question number 6. So from here on, we are looking at the members table. So we need diner data. Select star from diner data. Now we want items. Now we want orders that were made after becoming a member. So where condition is order date is greater than or equal to join date. So if you run this, so you can see these are the orders that were made after becoming a member. Now from this we want first item. So for that, dense rank over partition by, then customer ID, order by order date in the ascending order, because we want the first item at the top and the latest item at the bottom, as order rank. So again, we got the order rank column. Now we want to use this order rank column. So for that, we need a CTE. Always remember, every time you're deriving a new column and you want to use the new column in the further transformations like group by anything, you need a CTE. So select star from CTE. Okay, let me give a meaningful name rather than CTE. So we can write first order after membership. Again, it's kind of long, but it's okay. At least it's more meaningful than the name CTE itself. First order after membership. So if you write this, if you run this, yeah, we got the output. Now we want where order rank equal to 1. Now let's get the relevant columns, customer ID and then product name. Yeah. So for customer A, curry was the first item after becoming a member. For customer B, it was sushi. Now let's go to question number 7. Which item was purchased just before the customer became a member? So previously we saw first item after becoming a member. Now we are seeing last item before becoming a member, which means what was the item that made the customer take the membership. We want to know that item for every customer. So if you see for customer A, join date was January 7th. So the last order will be before January 7th, which is here you can see only on January 1st. On January 1st, the customer made 2 orders, sushi and curry. So this will be the last order before becoming a member. And for customer B, joined on January 9th. So the last order would be was January 4th, which was sushi. So we want to fetch these records. So let's see, we are using diner data. So select star from diner data. See again, you can see we only want items that were purchased before becoming a member, right? So again, say simple, where order date is less than join date. Previously it was greater than or equal to join date. Here, where order date is less than join date. So which is exactly opposite of this one. This one. So if you see, these orders will be fetched. The orders that were color coded in green color will be fetched once we run this code. Again, we want to look again. Simply perform the partition by customer ID. We are ordering in the descending order now. Let me show you. First, we perform partition by. Then customer A and customer B. We are performing partition by. Simple. We have partition by customer ID. Now here, if you see order by. So if you see for customer B, we have January 4th in the last. But here we see once you order in the descending order, because we want to know the latest order before becoming a customer. So which will be, so we are ranking in the descending order date in the descending order. So January 4th will be at the first and January 1st will be at the last, was the first item. See, order by order date in the descending order, order by order in the descending order, and finally when we apply this dense rank, we'll get a new column. We are naming it as order rank. You see, so for customer A, it was only one item before becoming the customer. So we have order rank equal to 1 for both the orders, because both of these orders are placed on the same date. For customer B, we have seen January 4th was the last order before becoming a customer. So that order was order rank equal to 1. Now again, now we want to see, only we want to get these orders where order rank equal to 1. So basically, again we have to write a CTE because we are using this derived column. If you see, again we are writing the CTE, which CTE as, again select star from CTE. Again we get the same output, same as this. Again we are wrapping it on, again we are wrapping it on a CTE. Now finally can perform where order rank equal to 1 to fetch those details where the orders that were purchased last before becoming a member. See, where order rank equal to 1, once you run this code, you will get this output. Again, when we select the relevant columns, customer ID and the product name. For customer A, it was sushi and curry. For customer B, it was sushi. See the final output and the final query. Now let's go to Databricks. Okay, now let's write the code for question number 7. Select star from diner data. Yeah. Okay, now let's write this. Now we want the order that were made before becoming a member. So where order date is less than join date. Anything before, every order that was made before becoming a member. So before joining the loyalty program. So these are all the orders. Again, we only want the last order before becoming a member. So again, we want a dense rank over partition by customer ID, order by order date. In the now here it's descending order. If you see previously, we want ascending order because we want the first item. Now we want the last item within the order that were made before becoming a member. So descending order as order rank. So customer B, the January 4th was the last order. The rank is 1. For customer B, the first order was January 1st, which was order rank equal to 3. So now again we need a CTE. So with CTE, again let me give a meaningful name. Last order before membership as select star from last order before membership here. If we run this, again we get the same output. Now where order rank equal to 1. Okay, now we don't need all these columns. Let's get the relevant columns, customer ID and then product name. See, for customer A, there are 2 orders again because we don't have the timestamp information, right? One order could be made in the morning and one order could be made in the evening, or both of them made at the same time. Again, we don't know. That's why we have customer A, it's sushi and curry, and for customer B, it was sushi. Okay, now let's focus on question number 8. What is the total items and amount spent for each member before they became a member? So we are only looking at the members. So again, so that's why we're taking the diner data. So select star from diner data. So this is the output we get. We see we are only looking at items for each member before they became a member, before they took the membership. So again, simple where condition, you can see where order date less than join date. So because we only want orders that were made before they took the membership. So these two orders satisfy the condition from customer A, and these three orders satisfy the condition from customer B. So if you run this code, we get this output. Now we are looking at exactly total items and the amount spent. So basically the count of these orders, and also the summation of this price. So we can simply do a group by. You see, we can perform a simple group by operation on customer ID. So again, if we split into two customers, because we only have two customers, the number of orders made were two. That's why the product purchase was two. Also, the price was total price is 10 plus 15, which is 25. Same for customer B. The total orders were 3. And then if you perform summation, 15 plus 15, 30, 30 plus 10, 40. So this is the output. Then how do you write the code? Because we are we're counting the number of orders we took. That's why we have count on product name, or count of star will also give the same information. So, and for price, we are performing the summation. Sum of price as total amount, which is 40 for customer B. And then finally, we are adding those. Once you run this code, you will get this output, and this is the final output. You see, this is the final output, and this is the final query. Now let's go to Databricks and write the code. If you go Databricks, so let's write the code. Select star from diner data. So again, we got the output. So again, we want only orders that were made before becoming the customer. So order date is less than join date. So now we got these orders. Now we perform group by customer ID, and then here we write customer ID, and then count of product name. Count of product name gives us total number of orders as products purchased, and then summation on the price as total amount spent. So if you run this, so we got for customer A we have two orders. Total amount spent is 25, and for customer B it's three orders at $40. Let's go to question number 9. Okay, now let's go for question number 9. If each $1 spent equates to 10 points and sushi has 2x points, how many points would each customer have? We are looking for all the customers. So we need sales details table. So select star from sales details. Now we need to derive a new column called points. For $1 equal to 10 points. So how many points we get in total? Again, but the twist is we have a condition. So in menu we have three products, right? Curry, sushi, and ramen. For sushi, we have a different logic. For remaining two products, curry and ramen, we have a different logic. For sushi, the price is $10, which means for $1 equal to 10 points. For $10, it will be 100 points. But for sushi, it's 2x points. So 100 into 2. So every time a customer bought a sushi product, they'll get 200 points. If it's curry, they'll get 150 points because $15 into 10, 150 points. And for ramen, it's $12, so they get 120 points. Now we need to use this logic and derive a points column. But the question is how to do it in SQL. So in SQL, when you want to derive a new column using few conditions, that's when we use case statement. Case statement is equivalent to if-else conditions in other programming languages. I color coded it based on the product name. Sushi, it's a different color. And for remaining other products, it's another color. So if you see, the code is case when product name equal to sushi, we have one logic. Else, for any other product, we have another logic. So basically, this is how the syntax would be, right? When product name equal to sushi. So again, focus on just at this point of time, just focus on when product name equal to sushi. Then, once you write this logic, if you see case when product name equal to sushi, then price into 10 because $1 equal to 10 points. For sushi, it's again into 2 because it has 2x multiplier. And for everything else, just price into 10. The difference is price into 10 into 2. Here, price into 10. As points, we are giving a new name. So in this case statement syntax, similar to window functions, at the end we have to provide a new name. So if you see, for sushi it's 10 into 10, it's 100 into 2, 200 points. For curry it's 150 points, and for ramen it's 120 points. Now finally we want to know how many points each customer made. This, now we derived points. Now we want to know total number of points each customer made. So simply we can perform group by on customer ID and then summation on the points to get the total points each customer made. Because we need to use this derived column, we need a CTE now. So if you see, with CTE as select star from and this code, and then select star from CTE, and then we are writing a group by customer ID. Again, when you write group by, it divides into 3 segments. It splits the data into 3 segments, and then we are performing summation on this points column. Summation on points column, as we are renaming it as scoreboard. So if you see the output, for customer A, it's 860 points in total. For customer B, it's 940 points, and for customer C, it's only 360 points. And then finally we combine the data. We combine this, then you get this, and finally we are performing in order by the customer who made more number of points will be at the top, and the least will be at the bottom. So customer B made more number of points, this 960, and customer C is at 360. We have code is order by scoreboard in the descending order from highest to lowest. So this is the final code and this is the output. So now let's go to Databricks and write the code. So let's write the code. Select star from sales details, again because we want all the customers A, B and C. So I think my cluster was terminated. Let me write this. Use catalog, SQL challenge, and use schema as diner. Yeah, if you run this, again we don't need this now. Okay, so if I run this code now, okay, great, we got the output. Now what we can do is, so let's derive a new column using case statement. Case when product name equal to sushi, then price into 10 into 2, again 2x multiplier, else product name, else price into 10, again end as points. So if you run this, you get 200 points. For sushi it's 200 points, for curry it's 150, and for ramen it's 120. Yeah, now let's write the, now use this column and find the total points. Now let's use this column and find the total points. For that we going to CTE with total points as select star from total points. Okay, if you run this, you get the same output. Now we need to perform a group by on customer ID, and then summation on the points column, points as scoreboard. Okay, we got the output. Let's perform order by scoreboard in the descending order. See, customer B got the most number of points, which is 940. Okay, now let's go for question number 10. In the first week after a customer joins the program, including their join date, they earn 2x points on all the items, not just sushi. So how many points do customers A and B have at the end of January? So there are multiple conditions going on in this question. Let's see one by one in detail. We have condition 1, only January orders, says end of January. And also we have condition 2 is, if the order was placed by a member and the order was placed within the first week of the membership, then they will get 2x points on all the items, which means basically they're getting a joining bonus. And for condition 3, whether you're a member or not, they'll always get 2x points for sushi and 1x points, only 1x points for other products like curry and ramen. Again, if I show you the final code, if you see here, we have in total 3 cities and the code is really long. So what we'll do is, rather than writing the entire code at the end, we'll go step by step. After every condition, we'll write the code and build on that. We need diner data because we only want details about customers A and B. We don't want about C because C was never a member. Second, select start from diner data. The condition 1 is only January orders. Customer B made an order on February 1st, so we need to eliminate that order because we're only looking at January orders. So we can simply write where month of order date equal to 1. This will be eliminated. All of these orders will satisfy the condition. This does not satisfy the condition. And this is the final output. Okay, so let's write till here. Let's go to Databricks. Select star from diner data where month of order date equal to 1. Run this. Okay, we got the output. Again, initially we have, okay, suppose if I remove this, see, initially we have 12 rows of data. When you run this, we have only 11 rows because one order from customer B is eliminated. So we have 11 rows of data. Yeah. Okay, now let's go to condition 2. Again, there are multiple things in this condition. So let's go within this, let's go one by one. Let's focus on membership. Okay, we are creating a new column called is member and saying whether at that point of time when the order was made, whether the customer was member or not. And just saying when these two orders were made, customer A was not a member. And when these three orders were made, customer B was not a member. Now we are flagging these orders as is member 1 or 0. If it's 1, the customer was member. If it's 0, the customer was not a member at that point of time. When you want to create a new column based on conditions, we need a case statement. Case when order date is greater than or equal to join date, which means when order was made after becoming a member. Then 1. Then 1. Else 0 and as is member. This new column is created because these orders were made when the customer was not a member. These are 0 and these are 1. Okay, now let's write the code till here. Case when order date is greater than or equal to join date. Then 1. Else 0 and as is member. We are saying when the order was made whether the customer was a member or not. See, okay, we got the output. Now let's go to another condition. Now when you became a member, whether that order was made within the first week of the membership or not. Because when you make the order within the first week, you'll get this bonus points for all the products. We have these 4 orders from customer A and these 2 orders from customer B were made when the customer were member. Now we are checking within this whether those orders are made within the first week of the membership or whether those orders were made after the first week. So for that we need to know end date of the first week. So once you know the end date, then we can check whether the particular order was made within those joining date and the end date. So now let's derive the new column which says end of first week. We want to know when will the first week end for the particular customer. For that we can use date add function. Once you have date add join date comma 6 again because we are also including the join date on the date you join, that is also that is considered as day 1. From the day 1 we add 6 more days, total 7 days, which is 1 week. Date add join date comma 6 as end of first week. So then you will get this output end of first week. So let's write till here comma date add join date comma 6. as end of first week. See, we got the output. If you see here, those end of first week dates for customer A, the join date was on January 7th. So 7th, 8th, 9th, 10th, 11th, 12th, and 13th. 13th will be the end date. Anything that was made after 13th, they will not get the joining bonus. Same for customer B, joining date was on 9th, and then the end date will be 15th. And any order that was made after 15th, if you see clearly, the last order was made on January 16th itself, which means one day after the joining bonus date. So you will not get the 2x points for this product. So because again it was ramen, which means you will not get the 2x points for this product. If this order was made one day before, then customer B would have got 2x points. Again, now let's go for this condition. Member and order placed in first week. Basically, we are saying whether that particular order gets a joining bonus or not. We are using these two columns and creating a new column called joining bonus. Again, because these are derived columns, we need a CTE to use these columns in the further transformations. That's why we are creating a CTE. With CTE as select star from CTE. All these orders were made by the customer A within the first week of the joining bonus. So all of these products will get 2x points regardless of the product ordered. But here if you see, for customer B, this product was ordered within the first week, it will get 2x points. This order was made one day after the joining bonus. That's why this product will not get the joining bonus. Now if you see the corresponding code, again we need a case statement. So case when each member equal to 1, and also order date is less than end of first week. So you have to become a member and you have to make the order within the first week to be eligible for the joining bonus. Then 1 else 0. If you see, this order date has to be less than end of first week, and also you have to be a member. Now once you run that code, you will get this output. Joining bonus is 0 0. Again, particularly if you look at the customer B, so this last order will not get the joining bonus because this order was made after the joining week. Okay, now let's go to Databricks. So if you see, again, we are using these two columns, is member and end of first week, to create a new column. So for that, we need a CTE with CTS select star from CTE. If I run this, yeah, okay, we got the same output. Now, case when is member equal to 1, you have to be member. Order date is less than or equal to end of first week. Then 1 else 0 and as joining bonus. So if you see, this last order will get 0 and the previous order will get 1 for customer B. Again, the same output. Now finally, again now we wrote till here. Now let's use this joining bonus column to derive the points. If I show you, now we are at the end. If you see, if you are member and if you are eligible for joining bonus, this is the condition. Anything other than that, this is the condition. So if you see, when each member equal to 1, and then you get the joining bonus. For these orders, for these 4 orders, each member equal to 1, the customer was member, and also he is eligible for the joining bonus. So at that point of time, we don't care which product the customer ordered, because all the points will get 2x points based on the price. That's why price into 10 into 2. You see, for these orders, again these are sushi orders. Regardless of whether you are a member or not, you will get 2x points because you'll always get extra points for sushi. Finally, when you are not a member and you did not order sushi, you'll only get 1x points. And also, if you are a member, but if you order outside of the first week, you'll only get the 1x points for curry and ramen. These three orders were made when these customers were not a member, and particularly this order we already seen. This order was made outside of the first week. That's why you'll only get 1x points. Again, because we are using this joining bonus column again, so we need one more CTE. We are getting a one more CTE as, and we are selecting the same CTE and we are adding the new condition, new case statement. When each member equal to 1 and joining bonus equal to 1, again same price into 10 into 2, regardless of the product. When product name equal to sushi, and now we don't care whether you are a member or not. If it's sushi, you will get 2x points, and for everything else you get only 1x points. Now if you write the code, so we need a CTE2 because we need a joining bonus column in the next step. So select star from CTE2. If you run this, yeah, the same code again. Now we need case when you are member equal to 1, and also you are eligible for the joining bonus, and joining bonus equal to 1. Then price into 10 into 2. So the second condition is when product name equal to sushi, then again price into 10 into 2, regardless of whether you are a member or not. Finally, we don't satisfy these two conditions, else price into 10, only 1x points. We are ending it as points. We are creating a new column called points, and these are conditions. If I run this, so we got the points. So if you see, if I show you here, because this customer ordered ramen, which is not a sushi, will only get 1x points, because outside of the membership you will get 120 points. We got 120 points for the last order. Yeah. Now let's club all of them. Finally, you'll get this output when you run this code. This output. Now what we want is, we want total points by customer. Again, so simply we can do a group by on this. Again, to do a group, again we are using a points column, which means we need one more CTE. We need CTE3 because we are using this new points column from CTE2. Select star from CTE3. Yeah, now here we need to use a group by to get the output at customer level. Group by customer ID. I show you here. Again, when you write a group by, it internally divides into two segments because we have two customers, and we are performing summation on this points column. Summation on this points column. If you see the code, let me zoom in. Yeah, group by customer ID, and finally, if you see, summation on the points column, and we're creating a new column called scoreboard. So if I write this, customer ID, summation on points as scoreboard. You see, again, this is the final output. For customer A, it's 1370 points, and for customer B, it's 820 points. So this is the final output, and we already wrote the final code. It's also provided here. Now we completed all the 10 questions. Let's go for bonus questions. Now that we completed all the 10 questions, now let's go to bonus questions. We have two questions. So basically what Danny wants us to do is, he wants us to recreate this table from the from the data he given us, from the sales menu and members tables, he wants us to create. Again, we already have this customer ID, order date, product name, and the price columns. We are just adding a new column called members and making sure whether it's a yes or a no. See, what he wants us to do is when the customer made that particular order, at that point of time, whether the customer was a member or not a member. We are adding that member status here. For customer A, we have when the two orders were made, he was not a member. When the remaining orders were made, he was a member. So for customer C was never a member. So all the three orders we have no. Because we are creating a new table completely, so I wanted to use the original table itself. If you see again sales and menu, we're joining sales and menu again here we're performing a full outer join because Danny is going to use this table in the future too. So there might be a new table, there might be a new product that Danny introduced in the menu. No one bought that product till then. So that's why we don't want to miss that information. If we use an inner join, we might miss that information. So we don't want to miss that information. That's why I'm doing a full outer join. And then we're performing a full outer join on members. See, we're performing a full outer join on again. Have customer ID here, and again we have product ID here. Again here, if you see, we get null values here because customer C was never a member and customer C information was never in the members table. That's why we get null values. This is the final output when you join the tables. Again, next what we are doing is we are adding a new column again based on a conditions. Again, whenever we want to create a new column based on conditions, we know that we use a case statement. If you see case when join date is null, see if you see the join date is null for customer C, or either join date has to be null, order date is less than join date. When you made an order before taking a membership, order date is less than join, then the value would be n, else it's y. Y is to indicate member. Again, we are creating a new column as member because the new column name is member. Again, once you run this, this will be the output. See, these orders were made before becoming a member, so it was n, and these orders were made after becoming a member. That's why the values are y. For customer C, all the values are n because customer C was never a member. And then you can see the output. Again, you can see the code. Case, again we are ending it as member. We are creating a new column. We only want 5 columns, so we are excluding all the irrelevant columns for us. So these two product IDs will be gone. Also this customer ID and this join ID will be gone. So we are selecting only these columns. So from sales we are selecting customer ID, order date. From menu we are selecting product name and price. So if you see, this is the final output. This is the final query. You can see here. So now let's go to Databricks and write the query. Okay, so let's write the code. Again, select star from. Again, let me define the catalog name here. Diner dot. Because we are creating a new table, I wanted to use the whole notation. So full outer join SQL challenge dot diner dot members. Okay, sorry, not members, menu on sales dot customer product ID equal to menu dot product ID. Then again full outer join on SQL challenge dot diner dot we have members on members dot customer ID equal to again let's have it here sales dot customer ID equal to members dot customer ID. Then if you run this, now we get the output. You can see for customer C we have null values. If you look at here clearly, yeah. Now let's write this. Let's create the new column called members. So case when join date is null, join date is null, or order date is less than join date. So I am making orders before becoming a member. Then we have n, else y. Then we are ending it as member. The new column name is member. If you run this, you can see for customer C, all the member values are n, which means customer C is not a member. Again, now let's only select the relevant columns. If we see, we want sales dot customer ID, and then we want say again what are other columns. Okay, sales dot order date, order date. Again, we want product name. Again, it's in menu table, menu dot product name, and then price and membership. Okay, now we have menu dot price, comma. Yeah, if you run this, again this is the final output. Again, let's also order by customer ID because we have A, B, and C, but the order was not proper here, A, C, and B. So let's also sort the data by customer ID, order by customer ID. Okay, which customer ID we have? Sales. Say, because we have customer ID in sales and members, right? So it will lead to ambiguity. So that's why we want to mention sales dot customer ID. See, clearly we have all the customer C as N for customer A. Then it's also perform an order by order date 2 in the ascending order. Order date. Ascending. Yeah. Now if you see the output, so these two orders were made when the customer was not a member. Again, then we have 4 Ys. So the same output you see again 3n's and 3y's for customer B, then 3n, 3y, and for customer C it's all n. The same output. Before we go to question number 12, I want to clarify one thing. I've seen this while I was editing the video. So one thing I claimed here, dense rank or the window function will execute first and then the case statement executes. Again, this may not be necessarily true all the time. The reason here in this case for this question, dense rank runs first or executes first and then case statement executes, it's because case statement has a dependency on this window function. Because of this dependency, window function runs first. I want to clarify that before we start. Now let's go to the last question. Rank all the things. Simply we are creating a one more column which is called ranking. The condition is if the customer was a non-member when the order was made, it should be null. When the customer was a member, the order should be ranked based on the order date in the ascending order. So first order was made after becoming a member for customer A on January 7th. So the ranking was 1. On 10th, the second order was made. So the ranking was 2 and so on. We're creating this ranking column based on this member. So simply we are creating this new column from the output of the previous table. So that's why, so which means, so these two are in natural progression. So if I show you, we need this output to create the new table, which means we can use this complete code. So what I'm doing is rather than showing you again, as you already seen this, I will use this entire code as the starting point for this next question. See, the same code is presented here. Again, because we need a new column, which is actually a derived column, we need a CTE to use this column. So with CTE as select star from CTE. Again, for this new column, we have conditions, right? If it's a member, we have one condition. If it's not a member, we have another condition, which means which naturally need a case statement. Again, we have a twist here, but if it's a member, we have to order the all the orders in the ascending order based on the order date, and then we have to add the rank 1, 2, and 3. So which means we need a window function here. So basically we are adding. So basically we are using window function inside a case statement. So if you see the code, we are using this. Again, this condition is easy when member equal to n, then null, and else when the order was made by a member, we have this window function. Now here the interesting thing is, even though it looks like case statement will run first and then the window function will run later, but actually it's reverse. Internally, at first the window function runs and then the case statement runs on top of the window function output. And why? Because this is how the SQL execution order works. This is one of the most confusing thing for a lot of SQL beginners. The way we write the SQL code is not the way it internally works. That's why visualization is tricky for a lot of beginners. The first of all, the window function runs. We are performing partition on customer ID. So I divided into three segments: customer A, customer B, and customer C. Three segments. The data is partitioned into three partitions based on the customer ID. We have three customers, so three partitions. Till here it's simple. Again, partition with customer ID. Again, we are also performing partition on the member also. Again, within these partitions, we have two more partitions because we have orders made by the customer A when he was a member and when he was not a member also. That's why we have N and then we have Y. Same for customer B, we have N as one partition and Y as one other partition. For customer C, we don't have any other partition because customer C was never a member. So we see again partition by customer ID, comma, member. That's a second call for partition. And then finally we perform a order by order date. And then we add this new column. Again, then we perform this dense rank. Again, we are performing this dense rank and we have this ranking column. See this new rank. Again, customer A made the non-member order only on one day. That's why the ranking equal to 1. And again, the first order was made on January 7th after becoming a member. That's why the rank equal to 1. On 11th, two orders were made. The same ranking for these two orders. Again, same for customer B. We have 1, 2, 3 even in non-members and also in members we have 1, 2, 3. So because only one order was made each day by this customer B. And for customer C, on January 1st, they made two orders. That's why ranking equal to 1 and 1. 1 and 1. On January 7th, the second order was made. So that's why the ranking equal to 2. Again, we are using dense rank here. If you use rank, this would have been 3. That's the difference between rank and dense rank. A rank jumps the number. Dense rank never jumps the number, it sequentially goes. Then finally, once this window function is performed, then it goes to the case statement. Here in case statement we see when member equal to n, then null. So all these values where we have 1 for non-member orders, they become null here. Here we have null, then here we have null. The column name is ranking itself. Again, when you club these two partitions, this is a result. When you club these two, this is one, and finally we have customer C. Again, this is the final output. When you run this code, when you run this entire code, this is the final output. Again, we are performing order by on customer ID and the order date, and this is the final result. Again, this is the complete final output and the final query. Now let's go to Databricks and write the code. Again, I already copy pasted the entire code from the previous question. So with CTE as select star from, let me drag this top, select star from CTE. Again, the cluster was terminated. Let me run this. So okay, if I run this, now we got the output, and now let's run this. We want to use the case statement. Case when member equal to n, then null. Then this is simple. Else dense rank over partition by the customer ID and then member, and then order by order date, the ascending order, because the first order after becoming a member should be rank equal to 1. Then we end it as ranking. So if you run this, so we got the exact output. we are looking for. If we go to the here 1 2 3 and 3, see 1 2 3 3, and we have nulls, we have 1 2 3 and nulls 1 2 3 and nulls. So this is the final output. So we successfully completed the case study 1. In future videos we'll be looking into subsequent case studies.